This is Santiago. He is an incredibly skilled hacker who was kicked out of MIT for being too smart. For months, he has tried to hack the CIA so he can release all the information the US government has stolen from its lawful citizens. This is Gonzalo, Santiago's hacking partner. He spent 10 years developing the most advanced encryption algorithm ever, and then hacked it in 2 days just for fun. With the combined power of their two 13-inch 2015 MacBook Airs, they finally might be able to hack into the CIA. In a few seconds, Santiago will activate the CIA Emergency Anti-Hack Protocol.
Warning, illegal breach detected. If you want to gain access, you will have to solve 3 ultra-difficult trigonometry problems in your computer, in which you will have to verify trigonometric identities. Say proceed to continue.
Oh golly gee, thank the sweet lord that I learned this in Miss Diana's lesson 5.2, verifying trig identities. This should be very easy. Proceed.
Question 1. Sine of x minus sine of x times cosine squared of x equals sine cubed of x.
Excellent choice. First, I must use my turbo factoring skills to simplify the left-hand side, because it is more complicated. We can factor out sine, like so. Oh, looks like I'll have to use the first Pythagorean identity here, because 1 minus cosine x squared is the equal to sine squared x. Great, now I have a very simple problem. Sine x times sine squared x is equal to sine cubed x.
Correct. Are you ready for question 2?
I'll leave the next one to you, Gonzalo.
Okay, what's the question?
Question 2. Cosecant of x plus cotangent of x times 1 minus cosine of x equals sine x. 5 minutes remaining.
Jeez, what should I do now? Identities maybe. I should remember the skills I practiced to remember all of the identities. I'm going to start working with the left side, because it is more complicated. Then, identities. Yes, I remembered. Reciprocal identities. I need to first simplify and use identities for both cosecant and cotangent. I know that cosecant is 1 over sine x, and that cotangent is cosine x over sine x. They are adding. What should I do next? I can spend a lot of time on this one. Got it. I have a common denominator of sine x, so I can just add them and have 1 plus cosine x divided by sine x. The next step, multiply. Oh, time is running up.
2 minutes remaining.
Okay, I will then multiply 1 plus cosine x divided by sine x times 1 minus cosine x, and that will put me do the distributive property with the numerator, which will be 1 minus cosine squared x at the end. Wow, here I have the first Pythagorean identity. 1 minus cosine squared x is equal to sine squared x, so it will make it easier for me to solve, as I now have sine squared x over sine x. I just divide and cancel with exponents, and finally get sine x. Bingo, let's go!
Correct. Santiago, are you ready for the final question?
Yes, I am 1,000,000,000% ready.
Question 3. Secant of x minus cosine x equals tangent of x times sine of x.
Holy Mary, Mother of Joseph! Once again, I must start on the left side, because it is more complicated. We can use reciprocal identities to change everything to terms of sine and cosine. Secant x is equal to 1 over cosine x. Next, we simplify using common denominators, like this, giving us 1 minus cosine squared x divided by cosine x. Lo and behold, the first Pythagorean identity comes to rescue. 1 minus cosine squared x is equal to sine squared x. Next, the quotient identity will allow us to simplify sine of x divided by cosine x into just tan x. And here, we've got our answer, tan x times sine x.
Correct. Access granted.
Finally, my life's work is complete.
Let's go. I'm grateful I know my trigonometric identities for this occasion. I now realize as without them, this operation would not be possible. It's time for the good game.
Today, we have witnessed a truly incredible deed. Santiago and Gonzalo are now being prosecuted by the US government for theft, but the lawful citizens now know that all their information is being stolen. Santiago and Gonzalo hackers, they would never be forgotten.